When we first introduced probability, we used it to evaluate inductive arguments. But knowing probabilities is important for other kinds of reasoning as well. The rest of this course will offer a brief introduction to decision theory, and that will include using our knowledge of probabilities to determine how outcomes can or should impact our choices about what to do. So this lesson will introduce decision theory, focusing on choices about whether to accept a gamble. You'll learn to recognize the core elements of a decision problem and to calculate the expected monetary value of a gamble, the simple decision we're going to look at. We'll start looking at decision theory in terms of bets or gambles. So let's begin with an example. Consider the following. Your friend offers to play this game. They'll flip a fair coin. If you flip the coin and it lands heads, your friend gives you $2. If you flip the coin and it lands tails, you give your friend $1. The question to you is, should you play this game? It might be pretty obvious already that you should. About half the time you'll win $2 and about half the time you'll lose $1. The best way to think about how to judge whether to take the bet is to consider what would happen if you play the game a bunch of times in a row. So if you were to play 10 times, you would expect to lose roughly $5 and win about 10. So over 10 rounds, that gives you a net gain of $5. Seems like a good game for you. Even this simple betting game can help us understand the key elements of decision theory. We reasoned that the simple bet would be a good one for us to take since we could expect to make money in the long run. In that situation, we're thinking of ourselves as the agent, the one who deliberates, makes a choice, and acts on it. We face a decision, we weigh our choices, and if we know what's good for us, in that case, we accept the game. Decision theory helps us understand how decisions like the one to play the game or not are made or how they should be made. So the purpose of decision theory is to give us mathematical tools with which we can explain the reasoning that underlies actual decisions that agents make, or with which we can explain what makes for optimal decision making. So here's some decisions we might weigh with decision theory. We could look at a simple one like, should you take the bus or drive to campus? We can also address more complex questions like, how do people weigh risk when making decisions? Decision theory will help us look at both types of questions. When we make decisions, we have to keep in mind the possible ways things might turn out, what choices we can make, and what the effects of those choices are. When we think about a decision as involving those elements, we get a sense of the three key parts of a decision: states, acts, and outcomes. So states are possible ways the world might turn out, and they're the ones that would affect our decision. In the betting example that we looked at right at the start, the states would be the coin lands heads or tails. An act is what an agent chooses to do in the face of a decision. So in this case, your action is play the game or not. And that's what you're trying to weigh. You're trying to decide whether or not to play the game, which action you should take. Which action you take will depend on what the possible states are and also the outcomes of your action. So the outcomes depend on what you do and on what the state of the world comes to be. So the outcomes in that are you win and you get money, or you lose and you give your friend money. That depends on you opting into the game, and it depends on the state, whether the coin lands heads or tails. In order to determine the cost or benefit of various outcomes, we want to calculate the expected value of each outcome. And for now, we're going to focus on expected monetary value. So the expected value is the amount you should expect to win or lose each game. And basically what that tells us is the average amount you should expect to get each round over the long run, if you are playing the game repeatedly. For a gamble, we want to distinguish the expected monetary value of a win from the expected monetary value of a loss. They're calculated in roughly the same way, but with a key important difference. The expected value of winning is the probability that you win times the amount of money that you win. And that gives you a dollar amount, how much you should expect to win. The expected monetary value of a loss is very similar. The probability that you lose times the amount you lose. But the key difference is the expected value of a loss should be given by a negative number. So now we know how to determine the expected value of a win or loss individually, and we need to put them together to determine the expected value of a gamble, where it's possible that we either win or lose. So we calculate the expected monetary value of a gamble by determining how much we win, and then we weight that by how likely we are to win, and we subtract how much we lose weighted by how likely we are to lose. So we have the expected value of winning minus the expected value of losing, or the probability of winning times the amount won minus the probability of losing times the amount lost. Let's use this formula to calculate the expected monetary value of the bet our friend offered. The probability of winning and losing is the same. So we plug that in for PR win and PR lose, and it's a half for each. That's because heads and tails are equally likely in our coin flip. When you win, you get $2. And when you lose, you pay your friend $1. At the end, that gives us an expected value of 50 cents won each round. Does that number make sense as an average amount we would expect to get if we were playing this over the long run? Well, earlier we found out that we would get $5 over 10 games, so that's about 50 cents a game. How does our friend fare given this expected value? Well, they should expect to lose 50 cents each round. So this formula here, filled in, represents their expected monetary value of this gamble. Monetarily speaking, it's a terrible game for them to offer, since they're basically guaranteed to lose money in the long run. To avoid losing money, though, your friend could charge you to play their game. So how much would it be fair for them to charge? The fair price of a gamble is the price that makes the expected monetary value of the gamble $0 for each of the individuals involved. So if we pay a fair price, our friend won't lose out in the long run, but the downside is we can no longer expect to gain in the long run. And in this specific case, if we were paying a fair price, you should expect to pay 50 cents per round to play your friend's game. With that, they wouldn't lose any money, but you would no longer expect to gain. Now let's consider another gamble and decide if it's worth taking. Let's say you're thinking about buying a lottery ticket. Tickets are $2 each. The lottery pays out $30 million. and the lottery plans to sell 20 million tickets. So you're only going to buy one ticket. That makes the probability of you winning 1 in 20 million. And since winning and losing are mutually exclusive, we can get the probability of losing by subtracting 1, the total probability, minus the probability of winning. That gives us the probabilities for our expected value formula. And then if you win, that rare case, you get 30 million. So that's our money won. But if you lose the $2 you spent on the ticket. So what's our expected value? It's 1 over 20 million times $30 million minus 19,999,999 over 20 million times the $2 you spent. That fraction is essentially 1. So you get 150 minus 2. So on average, every lottery ticket you buy is like throwing away 50 cents. Because your chances of winning that lottery are so low, you're essentially throwing away 50 cents every ticket you buy. Because the payout, if you do win, is so high, the amount you expect to lose is less than the amount that you pay for a ticket. But the chances of winning are still so low that the possibility of winning can't outweigh even the low cost of the ticket. So in terms of pure monetary value, lotteries are never worth it. So in this video, we've introduced decision theory as a way to choose whether to accept a gamble. And in the next few videos, we'll look at other kinds of decisions we might make, as well as other ways of measuring value.